new capabilities of electronics continue to amaze us. Consumers continue to look for products with more features. Features that provide more convenience, more comfort, and higher efficiencies and reliability. Electronics is the ideal tool to use in providing these benefits. Electronics can make it smaller, faster, and electronics can integrate. Integration is the combining of many controlling tasks into fewer components. Integration also allows functions to communicate with each other, like turn on the lights, but only after turning on the coffee maker. Now is the time for the use of electronic integration in HVAC equipment. Nowhere is this need greater than in the operating control of the domestic gas furnace. In the past, the control functions for these units have been in separate components. Controls were tied to each other and the controlled components by interconnecting wiring. Integration combines these controls in a single module. Wiring is simplified, system control is more accurate and safer. Energy savings is added, and troubleshooting is simplified. The integrated control is used in direct ignition gas furnaces. It is a microprocessor-based control that monitors and cycles the inducer or combustion blower, the igniter, the gas valve, and the unit circulating blower. Versions of the module also control power to a humidifier, which may or may not have a separate humidistat. Control of an electronic air cleaner is an additional option. In all, there can be as many as 34 terminals on the control. The terminals can be divided into 5 categories. First are the terminals that are used to bring power into the module. 2 voltages are used, 24 volts for control circuits and 120 volts to power line voltage components. 2 terminals are used to deliver unswitched power out of the module. These are the 2 120-volt terminals that power the primary side of the transformer. Next are the terminals that directly cycle system components. These are the blower motor, the inducer motor, the igniter, and the gas valve. There are a number of terminals that can read sensor status and switch positions. These include the room thermostat connections, pressure rollout and limit switches, and the flame sensor lead. In some versions, 2 sets of terminals control power to working accessories that are externally switched. These are an optional humidifier and an optional electronic air cleaner. The compressor contactor must be connected using the module terminals as the tie point in order to control cooling fan speed. The module does not cycle the compressor, however. Only the thermostat can cycle the compressor contactor. The source of all power for the module is a 120-volt direct connection from the furnace electrical junction box. This wiring must be made with proper polarity and ground connection. The hot side of the line must be connected to the hot terminal, and the neutral must be connected to the neutral terminal. If the 120-volt wiring is reversed, the module will lock out. The 120-volt line is routed internally to 2 terminals which power the primary side of the 24-volt furnace transformer. The neutral side of the 120-volt primary circuit is connected directly to the transformer neutral connection on the board. The hot side of the 120-volt circuit is connected to the hot transformer connection. It's important to note that these 2 terminals are at 120 volts line voltage to the transformer and are not an input from the transformer. The secondary side of the 24-volt transformer is connected at a 12-pin connector. The gas valve coil is connected to the MV terminals through the 12-pin connector of the control module. Similarly, the flame sensor probe is connected to the FP terminal at the connector. The connector also houses the limit switch terminals, the pressure switch connections, and the rollout switch connections if needed. The G&D terminal is connected to chassis ground. This connection must always be connected to the electrical service ground. The blower connections are made at the 1/4-inch spade connectors on the control board. The neutral blower lead, the cooling speed wire, and the heating speed wire are each connected to their respective terminals. Extra park terminals are supplied for attaching the unused blower leads. These terminals are electrically inactive. System blower control is completely handled by the module. No blower relay is used. Also, no fan switch is used. All timing of blower fan operations are controlled by the integrated module. In some versions, the blower delay times can be set by the technician using dip switches on the front of the module. On some models, heat on delay and heat off delay can be set. Optional versions also include timing delays in cooling for both blower on and blower off. The thermostat connections are made to the screw terminals on the board. Coding follows industry practice. The compressor contactor leads are connected to the Y and common terminals. Note that this puts the cooling contacts of the thermostat in control of the compressor. The compressor contactor is powered with 24 volts anytime there is a call for cooling from the thermostat. It is important to understand that the compressor contactor leads must be connected to the module in order to obtain cooling fan speed. For the versions of the integrated control that have air cleaner and humidifier options, the connections are made at the respective 1/4-inch terminals. Power for the air cleaner or humidifier is switched by the module. Again, proper polarity must be followed. The humidifier is only powered when the blower is running during a call for heat. The electronic air cleaner is powered anytime the circulating blower is powered. The igniter voltage is switched by an internal set of relay contacts. The inducer is also controlled through the same keyed connector. Control sequencing centers on 5 sets of circuits: the blower circuits, the inducer circuit, the accessory circuits, the ignition circuit, and the gas valve circuit. The ignition sequence uses direct ignition of the main burner. The igniter used is of the hot surface type. Hot surface ignition solves 2 problems common with standing pilots: nuisance loss of pilot flame and failure to ignite on call for heat. The igniter generates more than twice the energy of a standing pilot flame. This higher energy helps ensure reliable ignition under all burner conditions. The control system uses 3 components for the ignition sequence: an igniter, a flame sensor, and the gas valve. The integrated control keeps many of the ignition features of the White Rogers HSI system and adds some new ones. Remaining from HSI are multiple retries after a failure to ignite, multiple recycle attempts on flame loss during normal burner operation, fault-tolerant circuitry for pre-purge retry and recycle, and multiple external diagnostic codes. For added safety, the microprocessor performs an internal self-check of its own operation and the proper operation of all external safety and control switches. This check is repeated more than 16 times each second throughout each heating cycle. The ignition sequence begins when the heating contacts close on the thermostat. The inducer is energized to pre-purge the system for up to 30 seconds. A normally open pressure switch, reading combustion chamber pressure, closes on pressure drop. With the pressure switch closure, the igniter is powered for a 17-second warm-up time. At the end of the igniter warm-up time, the igniter is bright yellow and the gas valve is energized to allow gas flow. The flame sensor must detect flame within 4 to 7 seconds. The igniter is de-energized 3 seconds before the trial for ignition time has elapsed. Once ignition is accomplished, the flame is sensed by the flame sensor and the gas valve is energized open to allow gas flow. If flame is lost, the gas valve is de-energized within 2 seconds. This helps the flame signal to get established when the burner is cold. Once burner flame is established, the delay to fan on period begins. For two-stage systems, the inducer fan may go to higher speed, and the second stage of the gas valve may be energized. After the delay to fan on period ends, the blower is energized at heating speed. The optional air cleaner or humidifier circuits are also energized at this stage. When the thermostat is satisfied, the gas valve is de-energized and the delay to fan off period begins. After the delay to fan off period ends, the blower, humidifier, and air cleaner circuits are de-energized. If on a try for ignition the module does not prove ignition within the trial for ignition period, the gas valve will close. The module will then go into a retry mode. In the retry sequence, the inducer will be powered for a 30 to 90 second interpurge following a failed ignition attempt. The interpurge time varies with the module version. At the end of the interpurge, the ignition sequence is restarted with an additional 10 seconds of igniter warm-up time. If this attempt is unsuccessful, a new retry sequence is initiated. The module will continue to call for retries until flame is proven or the module locks out. The number of retries varies from one furnace manufacturer to another. The retry specification, as well as other module characteristics, is specified on the label of each control. The multiple retry for ignition eliminates nuisance lockouts. Any number of factors can cause a flameout during a normal combustion cycle. These include a momentary loss of gas supply, flame blowout, or loss of the flame probe signal. Should flame failure occur during normal operation, the failure is sensed by the flame sensor within 0.8 of a second. The integrated module immediately de-energizes the gas valve and restarts an ignition attempt. If at any time the flame remains established for 10 seconds, the module will clear the retry count. The control is now set for any flame loss period of 0.8 of a second or longer. The number of retry attempts following a flame loss also varies with the furnace design. Once a steady flame is sensed, the system operates until the thermostat is satisfied. The cooling sequence is much like that of a conventional system. The difference lies in the cool fan speed delay off. When the thermostat calls for cooling, the compressor contactor is immediately energized. If an air cleaner is used, it too is energized along with the cooling speed of the blower. After the thermostat is satisfied, the compressor contactor is de-energized and the optional cooling delay to fan off period begins. At the end of the timer period, the blower and air cleaner circuits are de-energized. When the thermostat fan switch is set to the manual position, the blower is energized on the cooling fan speed along with an optional air cleaner. When the switch is returned to the auto mode, both circuits are de-energized. The inherent reliability of electronics continues in the White Rogers Integrated Furnace Control. When service is needed, the diagnostic light on the module quickly points to the problem source. If the light glows continuously, the problem is in the module and it must be replaced. The module is not field repairable. A flashing light with pauses indicates a problem is most likely in the external components or wiring. The number of flashes between pauses is used to aid in diagnostics. The LED flash pattern helps indicate the probable location by the number of flashes between each pause. Check the White Rogers troubleshooting chart to match